Welcome everybody for BMP Summit. We have 3 speakers today. My name is Lakesh Sharma. I'm a BMP coordinator, and I'm organizing this BMP Summit with Dr. Michael Dukes and Emily Eubanks. The 3 speakers today, we have Cheryl Mackowiak. Cheryl is an associate professor, nutrient management and water quality at North Florida Research and Education Center. We have Jango Bhadha, assistant professor, soil, water, and nutrient management, Everglades Research and Education Center. We have Joel Love, BMP Educational Specialist II from Live Oak. All right, welcome speakers, and the floor is yours, Cheryl.
Thank you. I'm going to share my screen here. Hopefully you all can see that. And thanks for showing up. I'm going to give a kind of an entry-level overview of grid sampling versus zone sampling and what this all means in terms of precision ag and where we started and where we're at. I got into this just a little bit, so I'm by far no expert, but those that have a lot more questions at the end in terms of details, I'll be happy to help tie you into some of the folks that might have better answers for you. But at any rate, I work with some of the Veris equipment and have been working with that with the NFREC, David Wright, who's in agronomy, Sudeep Sidhu, who's an agronomist working with him, and Andrea Alberton, who's a water specialist in extension. And so by using that kind of equipment, you really have to start understanding what are grid sampling technologies and zone sampling and what that all means. So let's get started here. And just again, you know, precision ag and AI, you know, UF and IFAS are really starting to make a major push towards these types of technologies. That's kind of our new and upcoming thing, right? And everyone seems to be playing some kind of role in that area. So we're continually evolving new technologies and techniques in terms of soil characterization. But, you know, when you think about it, soil characterization outside of some surface scanning we're right back into soil sampling, and soil sampling is a long, tedious process, expensive. And so that technology is actually sort of falling behind. So until they start getting some newer sensors and that type of thing, we still have a ways to go. So you'll see more of that down the line here. Quick outline, I'm going to go over grid sampling, the past and present, zone sampling, the same thing. Soil nutrient influences and how that impacts these types of sampling. And then basically where we are today is kind of mirroring the grid sampling with the zone sampling. Does that lead to wedded bliss, or are there problems in paradise? And then finally, it gives you some examples of some of the on-the-go analysis and mapping in North Florida, basically using the Veris MSP3 system. So for some of you, 1961, which is about 60 years ago, sounds like forever. But for me, basically that was the year I was born. But to me, it doesn't sound that long ago. But that's when a couple of scientists out of University of Illinois, Champaign-Urbana, started looking at grid sampling in terms of basically, at least in this country, kind of the first that really gave it a lot of effort. And they really wanted a better way to assess a soil's fertility. You know, they're there in the Corn Belt, a lot of the big ag production's there. So they really want to make more efficient systems and get a better handle on how to manage the soil nutrition. So they had 40-acre fields. They had a couple of different locations, and they tracked pH, phosphorus, and potassium on 80-foot grids. And some of those went for a few decades. Then they went on to some more spatial geostatistics and interpolation. And this actually started coming about around the same time, more in the 60s and 70s. So now they're starting to get some statistics statistics support to help them understand what they're looking at and make predictions or forecast where these nutrient trends were going. So regular point grid sampling dominated through the 1990s. Okay, there we go. And so in terms of statistically interpreting those results, they moved from just some basic interpolation methods to what you've probably heard before, it was kriging, if you use any ArcGIS and those kinds of things. That started around the 1980s, and there's still some of that being used. Okay, one of the things with a kriging type of calculation is, unlike that point grid system where everything's equal distance in terms of your samples, this kriging type of equations actually work better when things are at different distances from one another. So having equal distances, you need more sampling points than you would with having variation in your distances and sampling points. So they've used some systematic unaligned grids, so they're not perfectly aligned. That helps in that to some extent. And then what was happening since the early 80s is that variable rate application equipment was being developed by different companies. And the thing is that's interesting is that the sampling, once again, was not keeping up with that technology. So, and you see this today where we have variable rate applicators and they can really refine how much they put over a given distance, but it's based on very rough estimates of what those nutrients actually are at those points in the system, right? So even today, you know, that's what, 50 years ago, we're still, or 30 years ago, or 40 years ago, we're still having some of these same problems. And the work up through the 90s, into the 90s, was mainly limited to Illinois, Wisconsin, and Nebraska. And I know at least in Nebraska, one of the researchers who got their PhD in Illinois moved to Nebraska. So that's basically probably why Nebraska was one of those key states. So it was a very small insular group that really did some of the early work. And it's probably in the last 20 years or so where things have really opened up. GPS was a major development, and they finally had enough satellites in by 1994. Again, 1994 isn't all that long ago. So you know, to get a good fix on a location, you need multiple satellites, and the more satellites you have, it's better in terms of accuracy. And it wasn't until 1993 where they allowed civilian use for these access to this type of data. So once GPS opened up to the public, then things really started moving along. Okay, so that's very quick in terms of the zone or the grid sampling, what were the early days. Zone sampling, I guess in some form or another, we've always been doing zone sampling since we've soil sampled, right? Because a zone or directed sampling is basically finding where a field looks different or performs differently and sampling that separate. So you might apply a different rate to a certain area versus just taking all your samples, compositing it, and having one value for that entire field. But people added a little more technology to it. So by the 1990s, they were looking more at some of these spatial nutrient patterns. They started with soil survey, but as you well know, soil survey maps are a great place to start, but they don't often tell you the true fertility of a system or changes in that fertility, especially if the soil series are fairly similar. Management has a big role to play in terms of what is really going on in those fields. So you can tell really coarse sandy soil versus a wet zone. Soil surveys are great with that, but to fine tune, they don't have that ability. But landscape position was another thing. And it was, in terms of landscape, think about that when you're sitting on top of a hill versus the slope versus at the bottom, especially in a depression or something. Where are the nutrients primarily located? A lot of times the nutrients are greater in those low areas at the bottom than they are along the hillside and that type of thing. So having a ability to know the elevation, well, that technology wasn't quite available yet. Not until we got into the 90s where there some ability to do that. Okay, and then they started looking at nitrate. Nitrogen is some of our, it's the most responsive real-time nutrient. It's required by the plant in the greatest amount. You really see that if you apply extra nitrogen to something, you really see that response in the plant in terms of productivity right away. So the other interesting thing with nitrates, or one of the plant available forms, is that it moves with the water. So by knowing topography, it was really easier to track nitrate or where the nitrogen was in a field by just knowing the topography of that field. So differential GPS is the GPS that includes elevation as well as your latitude, longitude. And then you're probably familiar or have heard the word LIDAR, light detecting and ranging. It's been around a long time also, since the 90s, but in terms of public use, it's probably in the last, 10, 15 years at most that we've really started seeing people using that. And it's very fine-tuned to very small changes in elevation. And so people are, in terms of precision ag, are making great use of that. So having those abilities help promote more of this zone type sampling by being able to delineate fields into these different zones based on topography. We have yield measurements now over geospatial measurements. And again, working on multiple layers and combining those layers to help define what those zones should be. Versus grid, it's just a set distance, and you just sample as high a resolution as you basically can afford, which isn't that high. So again, some of the parameters that help you determine what these treatment zones would be is the satellite imagery. How many of you use Google Earth? I do this all the time. I get a call on a field, and first thing I do, even before the soil map, is look on Google Earth and see if I'm seeing, you can see dark areas, light areas, if the field's been plowed at the time of the satellite image, or you can see where the waterways are and those types of things. Then go to your soil maps and look at what those look like. Electrical conductivity measurements, EC. People have only been using it around here probably in the last, 10 or so years, 10 to 20 years at most. But back in the 80s, Geonics out of Canada was one of the first companies that came out with this on-the-go EC measuring device. Veris, which I'll talk about a little later, came out in the 1990s. So these technologies aren't that new, but we're finally making better use of it. Having multi-year yield maps, as I mentioned before, we're better at doing that now. That helps additional aerial imagery. Now that we have drone technologies and they have filters on them, spectral filters to help identify potential yield problems, and layering these things using AI technology really helps and create much better zones. And again, sometimes we underestimate what the farmer's knowledge base is and their experience. Nothing better than a farmer with good experience of the field he's been working for 20, 30, 40 years or more. Getting that input could be invaluable as well. So if we look at, in terms of field uniformity, will help us determine what kind of sampling we should be doing. Okay, so EC values, so that's probably the most common technology that we have available right now for doing zone mapping. It could, because it's conducting nutrients, anything with a charge, we can get an estimate of nitrate or cation exchange capacity, but those things have to be calibrated. It's not giving you values, it's just giving you a signal, right? Others have found ways to look at that in terms of soil texture, particularly clay content, and soil water content. In fact, our own use of the Veris from season to season, if we measure where the soil moisture was different from one year to the other, everything shifts up or down because of that amount of moisture, which higher water content can conduct electric current better. Okay, so if you have a field, and they've done this with nitrogen filters and trying to determine when field needs nitrogen is looking at, they say nitrogen's the only limiting thing in the field. And this happens in some cornfields that are like 10,000 acres big and, things of that sort. So when they find these differences, they'll say, okay, that's where the nitrogen needs to be applied. Well, when you have multiple variables changing, which is the typical, especially in our area, it's hard to say, well, that's because of this one factor. And that's what makes it hard to use some of these technologies in terms of monitoring and applying fertilizer down the road. And again, the nutrient variability in a field. In general, I think of potassium's not too bad. Phosphorus is awful. I mean, you could take one step and the phosphorus can be, half of what it was where you came from. And then there's different variations amongst the different nutrients. So they're all over the place. But in general, more and more, some of the folks that work in this area are saying it's just really variable regardless. It almost doesn't matter which nutrient. At least the variability is high enough that we're not taking the best advantage of this variable rate application. So some of the things with nitrogen variability, 1 meter is, you could have fairly good variability. They've been using this to look at NDVI. You've probably heard of those sensors, part of the AI suite of instruments to assess nutrition. As I mentioned, phosphorus, really high variability. But in terms of phosphorus, it's really difficult. How do you address that? Because we don't have any real-time phosphorus measurement at hand. McGrath and Arnold just put out an article, it was like the last year or two, and they're saying, well, if you're trying to really address phosphorus variability, you really need to be sampling at a 1/4 acre or less to get a real good handle on phosphorus. So no one can afford that kind of sampling frequency or resolution. So we've got a long ways to go. And besides, even our analysis of some of these nutrients, phosphorus, the correlation of the measurement to plant response is like an R-square of 0.65. One is perfect correlation. So you can see there's a lot of mess out there, a lot of variability. Okay, as I mentioned, there's large variability. Even folks argue at the 1 meter grid level. So in terms of costs and effectiveness, the higher the variability in that field, and you probably have an initial assessment of what that might be. You probably need to go down to a 1 acre grid, which could be fairly expensive. But they say if you can't do that, then doing it at 2.5 acre grid, you're probably just throwing your money away. So something to consider depending on what the crop is, with the interest in the AI and how that's all going to be used. I mean, it's going to be every person, every customer, every stakeholder is going to have their own unique situation. I don't think one answer is going to solve everyone's problems, right? If you have lower variability, then you can get away with a 2.5 acre grid. I know a lot of times you see 5 acre grids being advertised, and that probably no one's promoting a 5 acre grid unless things are very uniform. And then it makes you wonder why do it at all, right? So some common sense comes into play with some of these things. So combining these two things, grid and zone sampling, initially really where we're at is that you do some kind of grid sampling. Okay, and the recommendations these days is 2.5 acres or less, unless your variability is really low. Okay, or if your target nutrients are fairly high, then if it's fairly high, you're not going to miss anything, and so you could do a less resolution. The bottom right there, I took from NC State. This just gives you some options on how you could grid sample. The uniform grid is what people are typically used to seeing. The offset grid, you can see there's fewer samples to make that up. and stratified random on the far right. Basically, they're sampling in the grid, but as you notice, this helps with the kriging analysis. They're not uniformly spaced from one another. Regardless of what point you're sampling, cell point, and the cell point's that little dot in each one, that point should be made up of at least 8 composite samples within a foot or two of that point. And the point is found typically by GPS coordinates. You usually put a grid down, they have the GPS locate those points. If you're doing, say, something like on the far right, or if they're uniformly within that cell itself in that grid, if you're trying to represent that whole grid, then you want higher number of composite samples, 15 to 20. Okay, so you can see the amount of time and effort it takes, even though, first of all, you're analyzing each of those points, right? And it's made out of composite samples. So someone's still got to pull those samples to make that composite. So it's not something that you just zip out and do in 10 or 15 minutes. Okay, typically, who's making these things are the providers. Usually they're associated with fertilizer company, Mayo, Helena, and there's probably some others now. They typically do the service with the agreement that you're going to buy the products from them, and they'll probably be the ones putting it out as well. But I'm sure there's variations on that theme. Okay, so your zones can be based on individual nutrients if there's something in particular you really want to know, or just general fertility, or other things. So, you know, it's really nitrogen. And basically we started with lime. Lime was the one that they really started doing in this area. And now they've gotten to more of the fertilizers. If you grid sample, you could probably wait, at least in the Midwest, they promote every several years. But if you've got like a hayfield that's pulling a lot of nutrients out, you might have to bump that up a little bit, or things that are going to change the balance and throw things off kilter. You might have to move that up. But once you have your grid, then they can create zones, and then you're just following up with zone sampling, which is a lot fewer samples. And that you'd probably do every year or two. Here's an example. This came from Mayo, but this was several years ago. So their cost per acre is probably gone up. Maybe it's closer to $10 for 2.5 acre. Again, they were offering the 5 acre option, but the picture on the left is based on a 2.5 acre grid. So you can see that's about a 28 acre area parcel. And so it looks like those are zones. They created 4 zones, but you know, each point is representing a fairly large area. And that's why doing it at a lower acreage would give you better resolution. They created those zones. They developed 4 of them. You can see in the top in the gray. It just goes through how they calculate what the cost is. So they have their grid sampling fee, which, you know, was $7 for the grid sampling. Then they're going to do variable rate application, because if you're going to grid sample, why not have the application be variable rate? That's where you get your savings. And so they have that fee of $7.50 an acre. And then they calculated the amount of lime that was required, the fee. And so they came up with about $1,160 for the cost for that field. Now, if they just did a regular application, they only had 1 sample to pull, right? Represents the whole field. It's a composite. Then they have their application rate, the amount of lime based on that, because in this case, their one value was 5.5. So they based it on 5.5 pH. So they applied about 15% more lime on this field, doing it just the regular rate, their lime fee. And so they're a little over $1,000. So by doing just one rate, they saved themselves $100. But by doing that grid, they also got the information of all the other nutrients too. It wasn't just of lime. And so for $100, that it may be worth farmers to have that. I think it is, especially as the technology builds. And again, just to visualize how this works, the picture on the left is basically grid sampling. From that grid, you can create zones to start with, and we're just focused on the orange part, so that's why it's white dots. And then on the right, for those other years, now you can just sample the zones themselves. composite within the different zones individually and follow those and then keep track of those. And if you're seeing some improvements or not, and then you can make an assessment. But everyone's farm is going to be different because management's different and what they grow is different. I got to hurry up here. This is something we got to start thinking about, and it's a little off the track, but in terms of when we have mixed applications, whether it's a fertilizer, you say, oh, well, we've got a better deal if you buy a 10 or 20-10-20 versus really all you needed was a 20-0-20. You're paying, whether or not you need it, you're paying for that, in that case, phosphorus, right? And so the same thing with manure or poultry litter. I know a lot in the Suwanne area use poultry litter. And basically, they were looking at the economics based on yield improvement. And what they're finding is if they just did a set rate based on a whole field analysis, single sample composited, they really didn't gain anything. Compared to that, when they did based on, say, the nitrogen, well, in this case, phosphorus and potassium, but the manure was put out on a nitrogen basis, they actually returned $2,200 on that manure application. If they applied it based on the phosphorus to get, because they were really low on phosphorus and potassium, they actually, the return on that manure investment was almost $7,000 per acre. Okay, so these are things that we don't really talk about much, but we really need to take those into account as well. And just quickly, again, it's a mixed blend, these manures, and in terms of plant requirement and manure composition, they don't match up, right? Especially in potassium. I mean, the amount of manure is much higher than what the plant needs, and you're paying for that fertilizer whether you're using it or not. Okay, things for in terms of initial sampling, beware of end rows where there's a lot of compaction, wet spots or depressions that are, especially if they're small little areas. You don't want that to skew your results, probably skew too high and you'll put less out than you need. Very highly eroded areas that had the opposite problem. Areas that had former farmsteads or especially animal enclosures, anything that had a lot of manure is going to really skew those results. In addition, stay away from the roadways or near the roadways that can really change your values, or where you've stored lime or similar products that are going to have an impact on those results. Soils that have a lot of kind of where things are out of whack, a lot of repeated manure applications, excessive irrigation, fields that were aggregated from a lot of small fields all combined into one big field, and they were all treated differently previously. When you have a lot of variation or expect a lot of variation, grid sampling really is, best way to start. Sometimes you can go straight to zone sampling if you already have other multiple data layers that you can apply to help you pick out what those zones are going to be. And again, think about the producer. If they have a lot of experience with that land over time, get their input. Okay, I've got just a minute or two. The Veris MSP3 is the one we have. The ones that the fertilizer companies use typically just have electrical conductivity. Ours has electrical conductivity, pH, and organic matter estimates. This is just to show you how this works for the pH. They actually have two probes. They're calibrated just like a pH probe in the lab with buffers and all. And that thing in the center there, it's showing you in action. That's the little cup, the scoop on the right is after, actually when it's all cleaned off, and you can see a little nozzle at the left tip of that cup where it cleans the probes after they've measured what's in the cup. The electrical conductivity is technology that's been around for 30 or more years. The cultures are where that those sensors are located, and we can get from 0 to 1 foot and 1 to 3 foot, and that's done simultaneously, real time on the go. And then the other one that's kind of new is basically you've got this shoe on the bottom of the pressing wheels to measure organic matter, and basically it's just a spectral assessment. And they're looking at IR and red light, and you can get the data separate, or you can do calculations on your own and do your own calibrations. But again, this is dragging along the surface of the soil, and the soil's then you can't, if you scoot it over vegetation, that's going to give you an erroneous reading. It's got to be in contact with the soil to get that soil value, and it's just at the surface. So we haven't used it much, but it's really interesting. It'll be fun to see what happens over the years. Okay, and this is just showing you how we've used the Veris in one of our sod-based rotations, which is broken into 4 quadrants. We've made mapping from the EC values. And what we basically find is we have our sands that have the lower EC values, and our a little higher textured soils will give us a little bit higher EC value. This is what the actual sort of the raw data looks like, where the EC on the left, organic matter in the center, and then soil pH on the right. And so you see the EC and the organic matter, it's continuously monitoring. So the data is coming in real time, basically. And then the gaps between those lines are, get my, all right, stop that. Okay, so the gaps are just basically where the tractor, so we don't have time to do like every single foot, right? So you'll space it every 15, 20 feet or so and go up and down the field. On the right, that's pH. And again, remember, that's a cup going in the ground. So it takes a little time for the cup to pull a sample, measure it, spray it, clean it out, and go again. So instead of tens of thousands of points, we have hundreds of points. Still better than composite sampling. Okay, these are the kinds of maps we can make. And then in this case, the Veris company has what they call data fusion, where they take some of these parameters and put them together in some equations. You could do your own as well. And then they come up with, say, the yellow zones were coarser, lighter texture soils, and the blue was a finer texture, a darker in terms of organic matter soil. The actual values that are on that screen are wet chemistry values that we looked at just to compare. And it you know, generally came out pretty good. We're looking at on-farm and looking at nitrogen, using the Veris to make these zones. Again, the lighter zones are one of the zones, and then the darker is another within 2 types of management. Management A is the control, and management B is a sod-based rotation. Okay, so you see that. And here again, he's showing the zones. This is Sudeep's work. And then finally, just some data, again, using the Veris to create those zones. And then he did his measurements on different nitrogen application rates. And in terms of quality, in terms of visual quality or NDVI values, he was seeing a good correlation. The zone 1 is on the left and zone 2 is on the right for 2018 on the top. So you see zone 2, everything's a little lower. And then 2019 to show that there's some repeatability there, at least in terms of zone differences. Okay, and I don't know why that came out in different orders, but basically, if you have more questions about some of this, especially how we're using the MSP3 right now, David Wright and Sudeep are really good to get a hold of, and Andrea is involved with that experiment, so she knows the day-to-day of what's happening there. I focus more on pasture systems, but if you have interest in that or other things that you're having a hard time finding someone to talk to, get a hold of me, and I'll tie you in. If I don't know the answer, I'll find someone that does. A couple of the EDIS documents that are out there, take a look at that might be helpful to you in terms of what you may be interested in. And I'll open it up to questions.
All right. Thank you, Cheryl, for your presentation. I really enjoyed that. We have questions. Actually, one of question is from me, and there is a question. We have actually a few questions. Before that, I would like to announce we have a no-till conference that Joe Love has shared the link with. Could you please, if somebody's interested, you can use this link to register. And if you have any question, you can reach out to Joe Love, the email that I shared. All right, so the question we have, Gary England, on a new field falling for forest, timber, avoid old burns and piles. I think it's a comment than a question.
It'd be good for that though. I think you could easily find burn piles, old burn piles with that.
Okay. How deeper your Veris can go in the soil profile?
In terms of electrical conductivity, there's 2 zones from surface to 1 foot. So it integrates that depth, and or from surface to 3 feet. And so the 3 feet, your EC values will tend to be lower than the 0 to 1 foot, depending, on what kind of management or what's been going on.
Thank you. Okay, we have a question. Bear with me, I have to read this. I have a question about zoning. It seems that zone mapping often arbitrarily zones into 3 to 5 zones based on EC. If they zone into 3 zones, for example, and the total EC variation is 1 to 4, we get zones with EC 1 to 2, 2 to 3, and 3 to 4. If our zone variability is 1 to 30, we get zones with EC 1 to 10, 11 to 20, 21 to 30. So how useful is zoning based on EC when EC variability is low? How wide should EC variability be to make zoning meaningful?
That's actually a really good question. Yeah, so it depends on how much the fertilizer is going to affect that EC value. So if your field's fairly well fertilized and you have low EC variability, and it depends what the actual values are, but you probably don't even need to use it. And then that's even the case with any of these grids or zone sampling. If you've got a real uniform field, there may be a few out there, and the fertility is pretty good, and the people have been managing and it's well balanced, it might not be worth the money for that. And you'll notice that from that's where you have to have other data layers. So, why are people using this in terms of the producer? It's based on yield. If their yield's really uniform and it's where it should be, I wouldn't waste money on zone or grid or anything. I would just, do regular soil sampling and make sure things are where I think they are. It's only when you're finding these yield differences in different parts of the field, because now you're losing money. And so then you're trying to figure out, okay, what's causing that? And am I putting out one type of fertilizer when I need another for this other area? The other is for environmental issues. If you're in an area where you're near waterways where there's a big concern of nitrate losses or phosphorus further south, then you may still need to use that. But EC is a rough estimate. And again, as I mentioned before, it has a lot of different factors that can play into those readings. If you have specific questions like you had about some values and that, we could probably work on that offline if there's a real world issue that you're having. But it's a good point. If the variability is relatively low, then it's not going to do you much good.
I think that you answered his follow-up question as well. All right, so we have a question, but are there other manufacturers with similar machines as the Veris?
Well, in the old days, there were a few out there, and then, Veris really dominated the US. I think there might be 1 or 2. You would think a lot of them would come out, but I don't think anyone's making a lot of money out of it right now. So Veris is the only one I really have any familiarity with, but I thought there was maybe 1 or 2 others.
Thank you. For zone delineation, does shallow EC measurement is enough, or is it to use both shallow and deep EC measurement?
I've looked at both. I haven't done any statistics with it, but just looking at it, it's basically just been the shallow that we've really paid attention to. Things like maybe calcium, magnesium, but the pH is going to give you some of that data as well, might be on a little bit of the deeper integrated. Or if you've had a lot of tilling and tilled in a lot of manure, those types of things, the deeper one may have more of a role. But for most cases, I'd say the shallow is really all you need.
Thank you, Cheryl. I have a logistical question. I work with my old professor in North Dakota State, where this Midwest is basically they use this EC mapping and zone mapping, grid mapping a lot, like 20 years ago, and it's still on some level the research is going on, but there was not good success on the adoption side. Although they in a grain production there are variable rate fertilizer applicators are available. Um, and the biggest challenge they faced was the support system from the industry, because if there is a variable rate nozzle is off, or the controller is not working, there is not enough support to correct that error on time, because they have to apply that on a 500,000 or 10,000 acres. How do you see that could play a better role in Florida, uh, in terms of logistical support, and obviously we are also growing vegetables, not grains only. So what's your thoughts about it?
Yeah, well, the ones that I know who are mainly doing this or providing this service are the bulk fertilizer spreader folks. So Mayo and Helena and those things. And then they have their own spreaders. And so they're the ones that are applying the fertilizer too. So if there's a bad nozzle or this or that, that's on them. And those pieces of equipment, I was talking to a guy who was out by, out by the dairy, and he was doing for silage folks, and he invested in a truck, and it was like, I don't know, $200,000 for one vehicle. And they don't last real long because all those fertilizers corrode them in that. And so it's a major investment. Farmers typically aren't going to have their own. I know one guy who has a variable rate applicator, and that's about it. But it's, especially Florida, where, vegetables, you're going to do what? Probably liquid fertilizer irrigation anyways. But row crops in that, it'd be too expensive for folks to do their own, because most of our farms are small to medium sized too. You have to be a really big farm to make it worth your while to take care of that on your own. Again, I think our big limit is that our soil analysis is still from like the 1980s, 1970s even, right? And so until we have real time, on the go kind of measurements of some of these nutrients, we're just not even going to make great use of that technology, I think. But that's my personal feeling.
Yeah, there's definitely attraction there. I was on a tri-siting meeting. There was a real-time soil analysis equipment. It was more than $100,000, but still you cannot use in the field. You still need to get it to the lab soil sample. It can do it for you. It was on X-ray diffraction radioactivity material that was used in that. Anyway, so I think Joel has corrected my link. The link is for webinar by Chris Nicholas on soil health assessment. So please, audience, if you are interested to join that webinar, please register for it. I think it's online on No-Till. Go ahead if you're interested in that specific aspect of agriculture. Thank you, Joel. All right. I don't have any more question, and I would say Dr. Michael Dukes will take it from here for the next upcoming two speakers and any related questions. Cheryl, if you can hang on till end of the webinar, this session.
Oh yeah, I want to hear what they have to say. Thanks.
There may be some questions that somebody may ask, and we can answer later. Thank you, everybody. Michael, court is yours.
All right. Thanks, Lakesh. Thanks, Cheryl. Well, Jango, Joel, the floor is yours. Soil health, cover crops.
Thanks, Michael. Thanks, Lakesh, and everyone for being present this afternoon. I'm going to share my screen. And we should be good to go. All right. So this afternoon, thanks to Joel, we've put together a short seminar on the topic of soil health assessment of cover crops. What I'm going to do is kind of set the ground information, give a little introduction about soil health and how we perceive it, And then Joel can go in and provide some case study information specific on some of the work that they have done. So to define what is soil health, well, definition that has been set out is it's the continued capacity of a soil to function as a vital living system that can sustain plant, animals, and humans. And the key here is the soil functioning capacity, which can depend on a number of criteria, such as nutrient cycling that's going on in the soil, the water infiltration capacity, water availability that is present in the soil, soil's buffering capacity, its pH, physical stability, and also habitat to kind of extend biodiversity in the soil. Why is soil health important? Why is everybody talking about soil health? Well, I'll be the first to tell you the whole concept of soil health is not new. It's just been packaged in a way for us to kind of easily understand it, to kind of break it down into different steps, into different compartments so that we can address it a bit more logically. But folks have been dealing with soil health for decades now. Why is it helpful? Why is it important? Well, they have shown that it can reduce fertilizer inputs, lesser weed pressure in your farming practices over the year, efficient to cycle nutrients much better, drought tolerance, allows moisture to be retained in the soil, increases biodiversity in the soil, soil stability, and also increased soil infiltration, organic carbon and organic matter. The last two, organic carbon and organic matter, if I was to pick which ones would be the most important, would be the two most important in my opinion. Why do I say that? And I may be a little biased in actually saying that, but here is a little cartoon to kind of depict that. Soil carbon, if you think about it, the presence of soil carbon, that's the keystone. That's the fundamental element for all soil, physical, chemical, and biological processes that are going on down below in the ground, in the soil. So it is very important that we kind of look at soil carbon. Soil organic matter is a good proxy for the carbon that is present in the soil. And what can we do to kind of improve or increase the carbon organic matter that is present in the soil? The way I see the future of sustainable ag, again, it's a personal thought here, but one would have to look at soil sustainability, water quality and its resources, and how we manage the nutrients. All three of these aspects will have to be kind of worked in tandem for us to address the future of sustainable ag, to be sustainable. It's not just about keeping the soils healthy at the expense of using a whole lot of water or dumping a whole lot of fertilizer at the expense of increasing our yields and then depleting the soil quality or water resources. So we have to start thinking, addressing all three of these together. Why is soil sustainability so important? Well, here are some numbers to drive this statement. Annually, almost 24 billion tons of that topsoil, which is typically your top 6 inches, is lost globally. So that's a huge amount of soil if you think about it. And even in the United States, approximately 1.7 billion tons of that topsoil is lost annually. What's causing this loss? What are some of the driving mechanisms? Well, wind erosion by far is the #1 cause. You also have runoff when you have excess rainfall. and if there aren't any catchments or berms at the side of your field, you could lose this soil as a result of runoff. And locally, we've also seen instances of a process known as soil loss via oxidation. And this concept of soil loss via oxidation is common here in South Florida in the Everglades agricultural area where I'm located at. We work on a lot of organic soils, muck soils, histosols as we call them. They have 60, 70, even 80% of organic matter, active carbon present in these soils. And if you keep these soils fallow, exposed to the heat, some hot summers of South Florida, you can lose that organic matter just through volatilization, through CO2. So these are some mechanisms in which we are losing our soils. And then if you look at the global soil degradation setup, you can see in the sub-Saharan area, those gray patches, which is without any vegetation. And also your red spots are kind of depicting areas where the soils have been highly degraded. So we have to be mindful of it on a global level. NRCS has been a very good organization to kind of slowly and steadily provide science-based research on the concept of soil health. And so they've come out with the 4 soil health principles that one could practice as a grower, as a farmer. First one being is to maximize continuous living roots. It means if you have a plot of land, if you have a plot of farm that you're cultivating, you want to make sure there are some living roots present in them as long as possible, for as long throughout the year as possible. You want to minimize the disturbance, and that goes to the whole concept of tillage. As a third principle, you want to maximize soil cover, right? You want to make sure that the fallow period is just as short as possible, or even during the fallow period, can we put some cover crops or rotate with some other secondary crops there? And then allow for maximizing biodiversity. Again, this may work, may not work in all instances, but it has been shown to improve soil health if you can maximize the diversity on your plot of land. The benefits associated with that is that you can control erosion, you can protect soil aggregates, you can suppress the weeds, provides habitat for soil benefits. It cools the soil and also conserves moisture. Again, these last 2 points are very critical, and I will show why. This is just a visual to show that, in our typical day-to-day life, we just see what's on top of the field, what's on top of the surface. We see if the field is green and lush, hey, that's what we want to see. We are happy with that. But what we have to kind of keep reminding ourselves is that there is also a lot that's going on below the surface, the roots. And that is kind of what is depicted here in this animation of this little image here, that what you are seeing on top is that cash crop or that cover crop, but right below, almost the same amount of biomass is being generated, is actually living below ground. And some of these root zones can be twice as much higher in linear length than the crop above ground. So we have to keep that in mind. If we just look at soil health principle 3, which is provide continuous living roots. Benefits of that is, again, some of these might be repetitive, but it increases microbial activity, and that can help mineralize some of the nitrogen and other micronutrients that might be present or immobilized in the soil. It can increase plant nutrition, vitamin uptake, concentrations with the mycorrhizal and bacteria association that might be present in the soils. Increase biodiversity, improves physical, chemical, and biological properties, and also helps sequester and redeposit nutrient and organic matter back in the soil. Here's a little image of data that was generated. And if you look at the yellow and the gray lines there across the year, you've got yellow as your soybean that's grown in the field, and that kind of lasts from June to say November. And then if you look at your corn that's grown as in biomass, again, over the period you've got from May through November. And what then? Well, if you had some cover crops that would go in during that fallow period from, let's say, October all the way through January, February, March, and even April, And you've got that blue line there, and that's the biomass, that's the root mass in the top 4 inches of that soil that you could be accreting if your program allowed you to kind of place these cover crops in the system and not simply rely on your cash crop. Again, if you look at principle 4, which is keep it covered as much as possible, what are some of the benefits? Controls erosion, protects soil aggregates, suppresses weed, conserves moisture, cools the soil, and provides habitat for organisms. Why is the temperature, why is keeping the soils cool so important? Well, here is a little indicator here with some points here. Ideally, you would like a soil to be around that 70 degrees Fahrenheit, give or take. And why is that? Because it's at that temperature that 100% of the moisture is used for growth. Okay? All of that moisture present in the soil now is plant available. As the soils get hotter and hotter, and as that temperature keeps rising, you see when you get to the 95 to 100 Fahrenheit range, 15% of moisture is then available for your plant growth, and 85% of moisture is then lost to ET, evapotranspiration. What happens if that heat index still keeps going further up? Well, if it pushes 110, 113 degrees, some of the bacteria species will start dying. And this is very critical. You know, your microbes starts to die. And if you push even higher, 130, 140 degrees Fahrenheit, 100% of the moisture is lost, and soil bacteria really start to die. And that is when you end up with those gray horizons that we showed in the soils with no vegetation and completely degraded soils. So that's why heat is important to manage. Here is a little visual of what in situ temperatures can look like. On the left, you have a field with cover crops. And if you were to place your temperature gauge in there, temperature was about 87 degrees. And then you have a fallow field exposed to the atmosphere through summer, and you've got almost 20 degrees higher there. So you're pushing that 100 mark there, something that you really don't want to do as far as temperature is concerned. And again, keep in mind, crop yields are typically limited more often by hot and dry and not so much so cool and wet. But again, that is debatable. Just some examples here for cover cropping. If one was to kind of pick some grasses, during the summertime, sorghum, millet seem to do well. And if you are looking at your fallow in the wintertime, you can look at rye, oat, grass, and wheat. Those are some good options that could be used. If you're looking at legumes, again, in the summertime, you've got sunhemp, cowpea. We've worked with both of those, and velvet beans. Again, these are legumes. You know, they have the ability to kind of fix nitrogen, especially in that root zone. You can see nodules there when you pull that crop out, and you can see that it can provide some nitrogen back into the soil. If it's the winter time, you've got clovers, welch, beans, fava beans, peas, and lupins. That could be alternatives that you can apply. Soil health assessment framework. This again is something that, with the help of my crew here in the Everglades Ag area and the Everglades REC, we have been able to develop this framework. It is not rocket science. What we are proposing is that if there is a grower that has plans to kind of adopt or has adopted already some cover cropping practice in the fallow period, we go in there, shadow their practice, collect soil samples before and after the practice, and evaluate it for a whole host of soil health indicators, and then provide that information in the form of outreach and extension back to our stakeholders. So this was a framework that we had put together maybe 5-6 years ago, and kind of still building on it and developing it as we move along. Our lab here at the Everglades REC has started to build capacity on what are some of these indicators that we can actually test. Here is a list of 10 different indicators that we have the capability of conducting in-house. We follow the Soil Health Institute's protocol of determining these indicators so that they are kind of, I want to say, at least nationally normalized as to the methods that we are using. So we've got soil pH, bulk density, water holding capacity, cation exchange capacity, organic matter, active carbon. Active carbon is kind of a proxy for the amount of your labile carbon that is easily mineralized. It's a very good indicator to assess soil health. Total phosphorus, extractable nutrients, nitrogen, and soil protein. Again, soil protein, it's an assay which gives you a good indicator of how that nitrogen is being broken down or consumed by your microbes in the soil. We use that framework that I just presented a couple of slides previously, and we received some funds through the Southern SARE program to do an on-farm research. And we used that framework to see if we could actually shadow some of the practices throughout the state on some of these farms and see how soils were behaving. So we had, for this initial project, we had about 8 or 9 collaborative growers. They've been listed here all the way in the Panhandle to down south in Clewiston, Henry County. And we received soil samples from them. We tested them for the different soil health indicators. And then we were able to share this information, not just with the individual growers, but also as a group, as a team with all nine farmers. And what we found was that this was an initial study. What we found that 6 out of 9 growers showed an increase in that malic P phosphorus as a function of cover cropping, regardless of what type of cover crops were grown. 5 out of 9 showed an increase in total P, and surprisingly, just 1, but it was consistent, that not many growers showed an increase in malic 3, that labile potassium that was present in the soil. So clearly, this was something we had to convey, that, hey, your bioavailable, your labile potassium is getting depleted. Either it's getting leached out or getting taken up by the cover crop. But after your cover cropping practice, you may want to apply some more potassium for your subsequent cash crop. Right now, we have funding through the Florida Specialty Crop Block Grant Program, where we've kind of taken this initial SARE study to the next level. We are facilitating some stakeholders, growers, if they have been cover cropping and if they would like the sites to be assessed by us at no cost to them. We are providing this service. Either if it is in the Southern Florida area, we go out there, do the sampling ourselves, or we ask extension agents to help facilitate, send us soils to our lab so that we can build on this database throughout the state of Florida. Lastly, I want to plug a special seminar that we are hosting here at the Everglades REC. It's on June 10th. It is in person as well as a Zoom link for folks that want to attend. It's related to NRCS support and initiative programs for the farmers. And so it kind of Rosa Reyes, who is a conservationist, district conservationist in Palm Beach County, will give that talk. And in addition to different conservation practices, cover crops will also be addressed. And some of the incentives associated with that will be highlighted and discussed. So if folks want to attend this, please make a note of this event and you're more than welcome to attend it. With that, I'm going to hand it over to Joel. Joel, I'll be happy to change the slides at your instruction. Thank you. We'll take questions at the end of both our presentations. Thank you.
Okay, Thank you, Jango. I'm Joel Love. I work with the University of Florida up here at the Suwanne Valley Research and Education Centers where I'm located. I have 13 counties within the Suwanne River Water Management District. And my primary responsibility is helping farmers implement BMPs on farm that protect water quality and conserve water. I want to talk a little bit about a on-farm demonstration project that was envisioned by and started by the Suwanne County Conservation District. Andy Jackson, who is the chair there, is always lamented about driving by all these fields that are foul, at least in the wintertime, that are subject to wind erosion and are bare, and says, what can we do to help farmers incentivize cover crops? So they came up with some money they had in their checking account. We got some SARE money, and eventually we went to FDAX and got basically just enough money to do very basic, buy the seed, buy inoculant, and do soil health testing, tissue sampling, some of those kind of things. This project's not randomized, replicated trial. This is basically exposing cover crops to growers. It's the goal of this project. And while we're doing this, we're trying to do a little bit of rudimentary soil health testing and observation to see what's going to go on, in this case, over the next 5 years. Now, we have 15 farms in 8 counties. Thankfully, 9 are integrating livestock grazing on these cover crops. I like to see that. All the farms we're asking to plant multi-species blends, something different that they're used to doing already, generally anywhere from 3 to 8 species. And it's something that'll grow here. We're trying to conduct soil health tests at least once per year. Sometime if corn or cotton that requires nitrogen, we may pull one. It's 4 weeks after they plant those 2 crops to see what's going on and see how much nitrogen is available to that cash crop. How are we getting all these cover crops planted? It's a struggle. Most time we use what the farmers already have available. The quick and dirty method is, for a lot of growers, is broadcast the seed and disc it in. And we know that's not the best because we bury some too deep, put some too shallow. Our depth is inconsistent. But through cost share up here, that has been a very good program. We've been able to cost share vertical till units, which generally incorporate seed shallower. We cost share no-till drills. Those things have helped us a whole lot, do a better job of cover crop planting, getting better stands, saving the amount of seed we've got to apply. And in some cases, we're using conventional grain drills. So methods are all over the board. This year, we actually seeded a cover crop into standing soybeans with an airplane. That worked mildly successful. We should have probably flown our pattern a little closer. I wasn't there the day we did it, but went back, looked at how that was done. But overall, very pleased, and you'll see a picture at the end of what that cover crop looked like in one of these slides, I think. We were also trying something new. We're broadcasting seed and peanuts before digging, and let the peanut digger incorporate the seed, and that's worked very well, especially for those who are wanting very quick grazing after harvest, and also if it's very steep land. If we wait till after peanuts harvest, we get still big rains and the soil is subject to erosion. So that has worked surprisingly well. Go ahead, Jango, and advance slide, please. All right, who are we using for soil health test? It was recommended we go with Ward Lab out of Kearney, Nebraska. I think I said that right. So you're going to see an example of what page 1 and page 2 of a soil health test report looks like. You get your basic pH, organic matter, P and K, all your secondary nutrients, micronutrients. But then you're going to get some other things like soil health or soil respiration, microbial active carbon, and then you're going to get a soil health score. You're going to get a recommendation on cover crop blend. So if the organic matter is real low, they're might tell you to put 70% of your blend be legumes and 30% grasses or brassicas. If your organic matter is getting better and your soil health score is getting better, you might see just the opposite. You might see 30% legumes and 70% non-legumes. So, and you're also going to get a crop recommendation. And generally what I've seen with these so far is they're very conservative on their nitrogen recommendations, very similar to what UF would recommend is what I've seen so far. Go ahead and advance the slide, Jango. This is the other one that I discovered after we got started, but this is probably the main lab that people in our area use is Waters Lab out of Camilla, Georgia. And now they're doing a soil health test. And you see it's a one-page report. You got an explanation on back what how they go through their methodology. Similar information, but looks different, and their soil health score may be different from what WAR does. And just remember, it's an index. And I can't tell you what all this stuff means myself. I'm learning just like Jango and everybody else. But just be aware, you know, if a farmers are used to using Waters Lab, they may want to get a soil health report from Waters instead of somewhere else. But there's other labs as well. They do the Haney test and some of these other soil health tests. Jango, go ahead. All right, so what have we observed the last 4 years? And we're getting ready to go into our 5th year, and it's hard to believe these years have flown by us, but we have around 10, 11 farms that we've been working with. We've added a few since then, so they're like year 1, year 2, and hopefully the funding will keep going so we can complete all 5 years on all these. We've lost one farm due to economy, went out of business, but overall we're still hanging tough with who we've got. So what are we hearing? What are we seeing? Farmers have been overall pleased with the blends. You know, some of them were hesitant. I've never done anything. I'm used to growing rye or oats and rye, and that's all they've ever done. And they know the cows eat that and know what it'll do at the end of the year. But, you know, we've thankfully with the incentives we have and me out there hitting them with a pitchfork, they've been willing to try these things. Here's the thing I've observed. Less tillage used, organic matter values and soil health scores are higher. That's just, you know, and that's just within the last 4 years. We have some farmers that are still in this cover crop demo using conventional land prep methods, and we don't see a whole lot of change. But where the guys are using strip till, no till, trying to minimize tillage, those things are changing. I had one grower tell me, and he's been doing strip till and some amount of cover crop before we started this project. It says, Joel, it says my pH values are holding. I'm applying less P and K. I need less nitrogen on my cotton. And then if I can get cattle in the system, I see even more benefits. So he has land with cattle and without cattle, and he's got the comparison to see what those differences are. Hearing a lot more interest in grazing of the cover crops, and I think if we're going to incentivize cover crops, the way to incentivize cover crop is put cattle out there, and then they have an incentive to plant a cover crop if they're going to get a value back from that. The weak link in all of this, we need infrastructure, working pens, water troughs, fencing, perimeter fencing. And then if a row cropper is not interested in livestock, he needs a marriage partner, somebody that's interested in bringing cattle in there if it's just for 90 to 120 days during the fallow period and grazing, and they work out some kind of arrangement where both parties benefit. And I'm starting to hear a little bit more interest in that. So looking forward to maybe get some cost share on that, or at least some pilot demo projects to at least demonstrate the concept. Cost share has helped with equipment to get cover crops established properly and timely. We need more. The timely part is critical. If we're going to get the value of these cover crops, we need to get them planted as soon after crop harvest as possible. The downside of that is a lot of these farmers and even farm managers on research centers are scared of these cover crops. How do we plant through all of that? And so they plant them late. And so when we terminate the cover crop, within a few weeks it's gone. There's nothing there. As Jango has just so well pointed out, when your soil temperature gets 120, 140 degrees, if you got a good cover crop on it, our livestock in the soil, as one of my farmers talks about, they get to live. When the soil is bare, they don't do very well. So think about that. Go ahead, Jango. All right, so I just snatched one of the examples out of our soil health demo. This one farm actually has cattle. He grows 2 years of cotton and 1 year of peanuts. I think we've been through the rotation twice now in the last 4 years. He's grazing, cover crop blends, and just look on 5/4, I pulled a soil health sample in 11/12/2020. So that's been 3-4 years now. The organic matter hasn't really changed a whole lot, at least in this case, in these two fields. And I kind of expected that because we dig peanuts and we disturb the ground when we do that. So that's not a big surprise, but how many of y'all would like to have organic matter of 2.3% compared to less than 1 I see in a lot of these fields? And just remember, these are loamy sands in Jefferson County where I live, so the soils are better. It's not a Suwanne Valley intersoil like we farm over here. So look at the soil respiration. If you can see that, I tried to change the color in the background. You see one of our farmers' cover crop blends. Soil respiration in 2018 was 29.9. Soil respiration on 11/12, 68.7. Why? You can make your own deductions. Microbial active carbon was 21.1%. Now it's 35.1. Soil health score, according to Ward Labs, was 6.9 the baseline year. Soil health score now is 12.02. Cover crop suggestion has changed. Went from 50-50 legumes, grass or non-legumes, and now it's 40% legumes, 50% grass. So just take that for what it's worth. Go ahead and advance the slide there, Jango. If you got any questions, my email is on the screen and my cell phone number. Garrett McCrae, who works for the Suwanne County Conservation District, he's the one that manages the money and is the district projects coordinator for the Conservation District. You can see his contact info there if you need him. And I did mention about a cover crop. This is Daniel Spragues. He is our county agent in Jefferson County, standing in a cover crop blend that was flown on with an airplane and soybeans. As you can see there, at this time of year, I think this was April when we got this picture, the dominant cover crop at this time is hairy vetch, but there's winter pea out there and clover and oats and ryegrass. But you can see hairy vetch really comes into his own late April, early May, and the farmer is going to terminate this. I think he's already strip tilled through it, and when it finally rains, he's going to plant soybeans in here. And I guess that's it, Jango and Michael.
All right, thanks.
Did I get us back on time or on time?
We're good. We got some time for questions. So attendees, please put your questions in the chat. We've got a couple pieces of information in the chat. Cheryl posted some other machines that are similar to Veris in their function. And Dr. Sharma, the other Sharma, Dr. Vivek Sharma, put a link to a researcher that was working on the mapping about 10 years ago. So I've got a couple questions as people are inputting their questions. You said that Waters Lab and then that other lab. Oh, I think it's Kearney, Nebraska, Joel, by the way.
That's correct.
But it does look like Kearney. Anyhow, you said those other labs. So if those two labs have different soil health, I guess, indices, is it fair to say that there's probably more than those two out there? Or is there a scientific agreement on what a soil health index looks like?
I don't know. I mean, I would like to talk with Ray at the end of this project and see what he thinks. And I haven't really talked with Waters a whole lot, but I think Cornell does soil health testing, and there's others coming online with different tests. So I think that's what you're going to run. And it's just like regular soil sampling, Michael. Everybody uses, different extractants and different interpretations. A lot more of the land grants are using maybe 3 now, so there's some consistency there. But
just to me, it just seems like if there's not some consistency on that, I mean, maybe it doesn't matter. Maybe soil health is regional. Maybe, you know, in the Southeast where there are coastal plain soils, that's one thing. And then in the Midwest, it's another thing. I don't know. I just had that thought. When I see inconsistencies like that, it drives me crazy.
It's a very good question, Michael. They are trying to normalize a soil health index that folks can use. The Soil Health Institute has been working on a set series. What they've started to do is rigorously define how the indicators are first to be assessed, and then use those numbers to develop a number, and that is what they call a soil health index. There's a lot of historic work that has come out of Cornell University and folks from that part of the country, looking at a lot of Midwestern soils over the years, and they have an index that they've developed and provided to their stakeholders for many years, and they still continue to do that. But yeah, right now, people are trying to kind of put all their minds together to kind of come up with normalizing one system that can be said, this is what we are trying to do.
Okay. Yeah, thank you. That's pretty normal kind of in the early days of, you know, learning things. You know, there's different approaches and they sort of come together. All right, we got a question from David Campbell. Where or under what circumstances did the farm show an organic matter increase? I think this is for you, Joel, because Jango, you have plenty of organic matter, right?
As I mentioned, I think in my presentation, where I've seen an improvement, or it seems, like I said, I've got a lot more of these to go through. I got reams of data to look at when we get done, or soil health test anyway. Generally where we, like I said, we're limiting the tillage, using cover crop blends and running cattle on them, or using like broiler litter. That's the things I see that are consistent. Because one of our farms chose to take his demo and put it in Bhadha grass and convert it back to grass and cattle, because just was struggling growing crops on it, and had bad pigweed problem. And I sampled it 1 year after Bhadha grass with no cattle. The cattle had not been integrated into it yet. I didn't see a whole lot of change from when the grass was put in. That surprised me a little bit, but once it gets the cattle integrated, I want to go back and see what's happened after year two. I don't have all the answers, I can tell you that.
I think if I could add, the blending is by far, at least that's what we've seen in some of our collaborators as well. As soon as you have multiple blends, cowpea mixed with sun hemp, and you can see a slight increase, or maybe a fraction of an increase in your organic matter. But over years, if they kind of continue doing that, you can have growers that have built on that little fraction with each fallow season that they do that. Another interesting point is to keep in mind is how deep do you want to test your soils? And that is also important to keep in mind. You know, a lot of times folks say, well, the top 6 inches, okay, that's one way of looking at it. But the biggest bang for a lot of times for these cover crop is right in that top inch or 2 inches, where you're going to see the most action that's taking place. So the further down you try to go, you kind of neutralize that effect. And again, that needs to be highlighted here, you know, that with these practices, it will kind of diminish its effect the deeper you go down into the horizon. And we've seen that. We've tested at different soil depths to kind of be able to see that.
Is there a measure for, or I'll hold my question because Danielle asked a question, and you should have seen the QR code pop up there a minute ago as well if you're looking for CCA credits. Danielle asks, can you please describe how you measured root mass? Also, was fresh weight or dry weight reported on the slide? That was a great example of why cover crops are important. So how did you measure root mass, and was it fresh weight or dry weight?
That was I'll be honest, that was a slide that we've used. Nathan Lauder NRCS soil health specialist had provided. I believe that was some work done out of Georgia, where he is based out of. I do not have the details on how that piece of information was estimated. If I was to guess, I would say root. I mean, we've done similar work here where we've actually pulled out the cover crop across a 1 square meter area to kind of evaluate its fresh weight. We've washed the material with DI water, the entire plant, dried it, and then weighed the dry mass as well. So it's done on fresh weight as well as dry weight when you want to evaluate the cover crop.
A question I had, is there a measure or metric for biodiversity within the soil?
You need a microbiologist.
Okay.
You would need, and yes, there are measures of doing that. We have tried to collaborate with some of Dr. Strauss, Sarah Strauss as one, another gentleman out of Fort Lauderdale, Dr. Wilm as well, who are microbiologists. And they are excited to work with us because they actually, I guess, do some DNA type of assessment to evaluate what sort of microbes are present. And then characterize them, because there are thousands of different species that you can rank them in, which are the good microbes versus which are the not good microbes as well. So those are the experts. But yeah, a microbiologist on site or on the team would definitely help provide that type of information.
And follow up to that, are there links to measures of biodiversity? I'm assuming higher biodiversity equals or leads to better outcomes in terms of crop health, crop yield. Is that a known thing, or is that still being researched?
Generally speaking, yes. Generally speaking, yes. And in fact, the Soil Health Institute has defined, they have divided soil health indicators into 3 categories. You've got the physical parameters, you've got the chemical, and you've got the biological parameters. Under the biological parameters, there are different assays, microbial assays that you can conduct on your soil to come up with some quantitative assessment for microbiology and diversity present in the soil. Again, that is a bit more tricky, a bit more technical assays to conduct, and maybe in a typical soil test you may not see that. They are expensive even to conduct those things. They are time sensitive, expensive. But from a research point of view, yes, as I said, if you have a microbiologist on team, it would make for some very exciting research to be able to see how microbiology and so how does the soil respire? How does phosphatase behave in the soil? How does active carbon get mineralized in the soil? At what rate? But more work needs to be done, and you need specialists on it.
So we have a couple comments coming in on this saying generally fungal to bacterial ratios are good metrics. And Cheryl points out that a lot of the biological diversity is still being worked out. In other words, taxonomy versus function. What does what is my interpretation of that. So good. Well, we have 1 minute left. Do either of you want to speculate on where we're going to be with cover crops in Florida in, let's say, 10 years?
I want to say the acreage, you're going to see an increase in acreage. If there is someone out there keeping a track on what's our current acreage in 2020 versus what it will be in 2030, that acreage will be higher. At least in my limited experience, I've seen a lot of our stakeholders knocking on my door, asking a lot of questions. They want to adopt to cover things that they haven't done, 2-3 years, and they want to try it out. Why leave the fields fallow in the fallow period? For us, it's summer when it's too hot and it's fallow down in South Florida. So yeah, they are ready to put in some cover crops in there. So that would be my thought. Acreage would increase.
Joel, any parting thoughts before we close out?
Well, I was just thinking about at least the Suwanne BMAP and the Santa Fe BMAP. At least in the Suwanne, I'm going off of memory, Michael. I hadn't read that big, thick document in a while, but there was a significant load reduction from adopting cover crops during the fallow period to keep nitrogen from getting in groundwater. So, you know, if it's that significant, we need to be looking ways of technical assistance and cost share or whatever we need to do to get farmers to on-farm demos to get that adopted. If that's you know, it's significant. I mean, I hear that in the Midwest where a fallow period behind soybean, which kind of surprised me. There was more nitrate coming out of that system as the soybeans degraded over the fall and the spring, and it was, you know, nitrogen come out the tile lines without a cover crop on them. Mm-hmm. So that was kind of surprising. So.
Okay. Well, we'll get back with you in 10 years and see if you were right or not. How about that?
I'll be here.
One last comment. Gene McAvoy says, we need more cover crops, I think he means. It pained me to watch this week as steady 25-mile-per-hour winds whipped across a 3,000-acre fallow tomato farm, stripping topsoil and causing visibility issues on the nearby highway. Yeah, I think we can relate to that this time of year. All right. Well, I think that's a good way to close it out. Thanks, you both. Michael. Appreciate it. And we'll see you on the other side. And everyone else, we'll see you next week for the next BMP Summit presentation.
Thank you.
Bye-bye. Thank you.
Thanks, Cheryl.
Bye.
See you.